The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, welcome and thanks for joining us. Today we'll be discussing physical security integration and access control. We'll focus on best practices. This is part 2 of a series, and we presented the first part of this series last month. My name is Keith Harris. I'm the marketing manager for LensSec. In my career, I use my expertise in helping customers learn more about physical security solutions. I've trained many types of people on video surveillance techniques and security topics. I want to tell you a little bit about LensSec before we get into today's presentation. Since 1998, LensSec has been partnering with customers and security integrators. We have a background working with many types of industries, including schools, commercial projects, hospitals, universities, and the oil and gas industry. LensSec helps customers develop enterprise solutions for complex physical security projects. We've developed a powerful security platform called Perspective Video Management Software. This enterprise VMS streams and captures IP security video and incorporates video analytics, access control, and more into the software. Let's go over a few logistics for the webinar. If you have questions, you can enter your questions into the GoToWebinar panel. We'll collect those during the presentation and answer questions at the end of the event. We'll have a few poll questions during the presentation as well. You can answer those questions when they're presented. At the end of the webinar, we'll present a survey for attendees. We ask for you to answer a few quick questions for us and help us better serve you in webinar events in the future. If you're interested in a completion certificate for today's webinar, let us know when you fill out the survey. We'll follow up in a few days after the webinar with certificates, answers to questions, and a copy of today's presentation. We do record these webinars. We'll post them to our website, and we'll provide you with the link to the webinar video archive. You can see the link here at the bottom of the page. LensSec sponsors our Step Into Security monthly webinar, and we cover a variety of safety and physical security information. Please check back with us often and find out what's coming up in our next Step Into Security webinar. So today's webinar covers physical security systems integration with focus on access control. As I mentioned, this is going to be part 2 of the security topic we began last month. We have so much good material, we decided to break this webinar up into 2 events. Previously, we talked about the components in an access control system and physical security concepts. Today, we'll discuss access control management software features with a focus on enterprise-level products. We'll also talk about unifying physical security platforms. There are many best practices for access control deployment and a few unique features that we'll cover. And finally, we'll do a quick review of components covering some of the materials we discussed in part 1 for those that haven't seen it yet. So let's get started. First, we'll take a look at access control management. It's usually provided by a software product that lives on the server. This provides a user interface as well as control for the entire system. Access control users typically know about locks, readers, and credentials because they can see or use them. But management software is where everything comes together to make the system functional. The elements of access control management are fairly standard and have distinct functions. However, products from different manufacturers will vary the appearance of the user interface. Terminology used in the software will also differ from product to product. The main view is usually the live interface. That's where the user can see the current status of the doors in real time. Door management is where administrators can configure devices, providing the ability to add and revise door controllers and readers. Also in door management, rules and schedules allow the administrators to set user parameters. Under cardholder management, administrators add, edit, or delete user information. And administrators can all set up work groups that have different roles. privileges are granted to users based on the rules being used, and many will use the term privilege and permission interchangeably. Users and credentials need to be set up and managed in the cardholder management section. Reporting is an administrative feature that queries activity logs, compiles reports from the database, and creates a report that can be exported for security review. Let's take a look at these elements in a little bit more depth. The live view interface displays the current state of the system. It will show if doors are locked or unlocked, and it will show which users are accessing doors. The live view will show doors, will show the door events, and when people present their credentials at the reader, they'll be at the door and the event is logged. In most systems, you'll be able to see these as they occur. If your door controllers maintain a continuous connection with the server, not all do, so if real-time monitoring is needed, make sure your system has this capability. Any alarms will show up here in the live view. An alarm event is logged when a door is forced open in a brute force attack. If the door is held open too long or an invalid credential is presented, an alarm event will occur as well. Usually in the live view interface, you'll be provided with the opportunity for performing certain actions, such as locking or unlocking a door from the interface. Authorized personnel may also initiate a lockdown operation in the event of an emergency. If IP cameras are integrated into the access control software, then the video could be monitored in the live view interface. Let's take a look at our first poll question. I'll get that launched here for you. So, user control access rules apply to doors. Do they apply to users, doors, or users, depending on the access control system? Do they apply to neither, or do you not know? So those are the choices. Make your vote there, and we'll take a look at our responses in just a moment. Give people just a moment to get those votes in. While we're doing that, we'll take a look at, talk for just a second about the smash and grab brute force attack. A lot of times when a brute force attack occurs, you've got an access control system tied together with other systems. You can capture an event, for example, a recording from an IP security video camera as the event occurs. So there's a feature called pre-roll video that gives you that opportunity if you've got the systems tied together. We'll talk a little bit more about integrating those two systems in the coming slides here. All right, let's close our poll and launch the results. Looks like our results here showing 100% say that doors or users depend on the access control system. And that's exactly right. If we look ahead here in our door management, taking a look at rules and schedules, we'll see that that is exactly the case. Door management functions that configure openings provide administrative rights to add or change door controllers. The administrator can adjust settings for each door from within the access control software. Some proprietary systems are hardwired and use dip switches to set devices, but administrators using IP-based access control software are configuring their devices in their door management section. Device configuration helps to ensure doors open upon authorization, and they remain locked depending on the user permissions or schedule. Rules and schedules allow the administrator to set restrictions for when credentials may be used. This will configure times and dates that users may use their credentials or be blocked from entry. Some systems apply the rules against specific doors. Other systems associate the rules with specific cardholders. So it's going to depend, again, on the system. as to which that's going to apply to. In enterprise-level systems, certain employees may be restricted from access based on schedule, while managers, for example, may have the ability to access buildings during off hours. Scheduling seems simple enough. The feature prohibits after-hours access, but consider the holiday schedule. It's a Monday holiday. No employees are scheduled to come into work, and you don't want the doors to unlock, leaving a facility vulnerable. Let's see. Let's get you back in here. Sorry, I left that slide up a little bit long. So let's look at the holiday schedule. It's a Monday holiday. No employees are scheduled to come into work, and you don't want the doors to unlock, leaving the facility vulnerable. Access control scheduling can take that into account, and administrators may block specific dates and keep the building locked. If you have a unique scheduling scenario, such as an evening meeting, the administrator can schedule the doors in advance to unlock at specified times. This gives them more freedom instead of having to schedule someone with a key to be on site to unlock doors. The cardholder management function gives administrators control over users and credentials. Administrators configure user access privileges and assign credentials in this section. Let's take a moment to discuss groups and roles, as these two can be confusing. For example, a shift manager can be placed in a group with other shift managers, and a security guard can go into a specified group for guards. These can be split up based on different groupings that work like shifts. The arrangements can be limitless with advanced software capabilities across an enterprise. A user is an individual, and a group is a collection of users. These users might have different job functions within the company. A role can be activated according to specific conditions, such as job activity. For ease of explanation, it can be like a job title. You might have a role that fits into many different groups, and groups tend to focus on identity, not on the role or activity. Users will be assigned roles and associated within their appropriate groups. The user is assigned, and a specific user credential, such as a key fob, is issued. User management also allows administrators to print employee badges if the system is set up for that task. Reporting keeps track of log details collected by the system. This is usually a database that can produce various types of reports for forensic review. Reports may identify such information as specific user access, door locations, lock status, date and time, etc. All right, now when looking at access control levels, not all deployments are equal. In a small business, administrators may use a flat configuration. This setup allows users through all doors at any time. All credentials are considered equal. This is not an enterprise setup, however. It's basic, and it requires very little administrative planning. While this is easy to set up, it may not meet the security goals for a larger enterprise. It introduces certain operational vulnerabilities. There's no accounting for who's using credentials or gaining access to sensitive areas at any given time. So setting a more advanced configuration in an enterprise system will close the operational vulnerabilities. Advanced configuration enhances security and provides three key benefits. By using system segregation, management can keep unauthorized personnel out of secure areas. This restricts certain personnel from sensitive areas or after-hours access. System segregation can also permit authorized users to gain access to those areas while still logging the activity for reporting purposes. Accountability is also a key factor in setting advanced configurations. Credentials are not commodity items. They shouldn't be passed around from person to person. Credential holders are now accountable for their card and its usage. Cards shouldn't be loaned out and should remain with the designated user at all times. Escortability means that visitors are restricted from accessing secured areas unless they're accompanied by an authorized employee. So you see, an advanced configuration leads us to really planning out our roles, groups, and permissions. You can see here we've defined a well-planned access control system that has a multi-tiered access level. Group 1 might represent management and have access to all doors. Groups 2 through 5 access have access to their authorized areas, but are restricted from non-essential areas. Let's consider this security guard. The security guard has access to the school building 24/7. However, there are a few areas that we want to restrict him from entering, especially during off hours. You'll see here we've given him access to most of the interior area doors. However, there are 3 network closets that house servers and security equipment, but our guard doesn't need to access these sensitive areas. So we can assign permission to the guard to gain access to the doors where he's allowed, and we can restrict permissions based on blocking the entry from the unauthorized areas. Now, on the other side of the coin, let's take a look at another role, the IT contractor. He has very little access to the building 24/7. He can get into the front door and the 3 network closets, and nothing else. We can assign permissions to the contractor to gain access to the doors only where he is allowed, but only on a limited basis, not necessarily 24/7 access like the security guard has. And like the security guard, we can restrict the IT contractor's permissions to block entry from unauthorized areas. A large company may have very unique needs that require an enterprise access control system. The company might have hundreds or thousands of employees working at widespread locations. And the system could be managing thousands of doors. Multi-site management will be key in arranging all this information. Each site can be managed under the umbrella of the enterprise software. For example, an employee can hold a credential from Site A, and when the employee travels to Site B, an administrator can temporarily grant privileges for access and rescind that privilege when the visit is complete. A regional employee can be granted permissions to several regional facilities and restricted facilities outside of his region. A local administrator might be able to see and manage his local site, but may have no ability to see or manage another site. And a global administrator might be able to access and make changes to all of the sites from his remote location. Possibilities are countless and significant in an enterprise system. That's what makes them valuable. Third-party integrations with other systems is common in an enterprise system. It could be with payroll, visitor management, accounting systems, for example. The system management and databases for these systems can grow very large, so large that a dedicated server hardware might be required. Data and permission rules can exceed tens of thousands of records. And this will require an SQL database to manage all of this information. Single sign-on is an enterprise system feature that enables users to log in once and subsequently access multiple computer programs. It's often done using Active Directory or LDAP, and it's available typically in an enterprise system. The administrator sets up user access, and the Active Directory tracks login and logout of the user. This not only affects operators that monitor access control live view, but also affects addition and deletion of cardholders. If an employee is terminated or quits, the administrator can immediately remove the name of the user from the system, locking them out of all computer and building access. Any changes made in the Active Directory system will push out changes to the access control system. When an enterprise-level access control system is in place, a lot of companies want to unify their physical security platforms. This can be done by integrating physical security systems. The goal here in integrating systems is to allow the systems to work in unison with one another whenever possible. The access control software and the video management software may be able to display critical information from both systems in a single interface. This requires careful planning and research in advance of the equipment deployment. Manufacturers of the two systems have typically agreed in advance to make their systems compatible. Understanding exactly how the two products interact should be a high priority very early in the project. And there are several good reasons that integrating your various security systems makes sense. Security managers are looking at this due to an increased awareness and need for life safety. There are many security concerns, terror attacks in public places like we've seen recently, domestic violence, robberies, burglaries, general mischief, and more to watch out for. In larger deployments, many different security systems are covering different duties that are part of the overall security footprint. Combining data across various security platforms can improve your situational awareness if the integration is managed well. For example, when you tie intrusion detection systems in with the IP cameras and video surveillance systems, the security platform is one step closer to becoming more effective. When an event occurs, the recording frame rate of the security camera can be ramped up to provide better image quality, is one example. Access control systems can send alerts to the video management software and trigger event recording for later review. VMS integration in access control software will usually display live video feeds next to the badge photos, so operators can visually verify the person entering as a valid employee. Lockdown systems are making their way into schools as well. These systems will perform a series of actions when lockdown is initiated. Not only will appropriate doors lock automatically, but first responders may be notified, and a mass notification system for parents and district personnel could be triggered. Physical security systems are also frequently integrated with building safety systems such as fire alarms or even HVAC systems. Video verification is a function that allows users to visually identify people at the door. This feature monitors access control software and displays a live video feed within the live view interface. People can be seen as they approach the door. The operator can compare the badge photo of the employee with the live video of the employee to verify the person making entry. The operator may even be required to grant access by manual authorization in certain circumstances, say requiring a person to present their credential at the car reader and then manually unlocking the door. Visitor management software can help provide an additional layer of accountability. No one is allowed to enter without first logging in. This system can log entry for employees and visitors, but it also can typically associate unknown people with their sponsor, typically a permanent employee. Visitor management systems provide a heads-up visibility so employees can verify authorization. A temporary badge is issued, and the visitor will display that where it can be easily seen, and this keeps employees from wondering if an unknown visitor belongs in a certain area or not. Visitor management software is usually equipped with several peripherals that make it full-featured. The workstation may have an ID camera, a badge printer, and an ID reader, and possibly a barcode scanner. Time and attendance software helps to improve the overall picture of an employee's work record, because the time date stamping with events, an administrator can provide a concrete record of where a person was at any given time, such as when they clocked in or out, or even if they were in attendance on a given day or not. Some access control systems can be adjusted to use time logging with time clocks. These features can help protect both the company and the employee when verbal discrepancies arise. Even punching the clock can be cross-referenced with door access or security cameras for confirmation when necessary. Now let's take a look at mustering. Let's launch this poll question here. Our second poll question. What is mustering? Something you put on a sandwich? A technique for testing a server before deployment? Assembling the troops during inspection or events? A process for cutting into a door to install a mortise strike? Or I don't know. Those are your choices. Go ahead and make your vote, and we'll tally our votes here in just a moment. Almost there. We'll give just another couple of seconds to get your vote in. All right, let's check our results. There we see our results. We're showing 50% say a technique for testing a server, and 50% say a process for cutting into a door to install a mortise. The correct response is assembling the troops during inspection or an event. That's actually what mustering is, and we're going to talk about it here in just a moment. All right, so when we look at mustering, that kind of falls under the one of the best practices for access control. Now, not all of these will work in every situation, but they're worth considering when certain needs arise. Mustering is a method to answer the question, did everyone make it out? It's a deployment feature that immediately evaluates employee locations in the facility during an emergency situation. Mustering is an assembly of employees. It was actually a military term first, an assembly of troops. And in our situation, we use it either during a drill or during an emergency event. Now, with technology, management can immediately see who's checked in at a muster point or not. Proper and careful design is essential for this feature to be enabled. There's two types of mustering, area tracking and checking in. Area tracking uses access control to generate a roster of occupants in certain areas. Every time an occupant scans a card to enter or leave an area, the access control system logs the time, date, and the credential holder. But that data can be pulled up in a report immediately, sometimes even on a mobile device, to see who's in given areas at given times. Checking in is another implementation technique. It's sometimes, some systems use mustering as an opt-in control. So a credential reader would be located at an evacuation point. It's scanned as cardholders reach that location. Then that list of names can be compared against the assigned list of evacuees who should scan into that reader during an emergency. That way they know at given points in time. Anti-passback controls help manage passback problems and are generated, that could be generated by sharing credentials. Technology can prevent this with certain controls. Access control can be set to a time limit, and this is essentially a problem of people sharing their credential, passing it back through so that somebody else can swipe in and use it. So access control can be set to a time limit. A card can't be used at the same reader twice within a certain amount of time. This prevents the user from handing off the card to another person trying to beat the system. Reader and pattern flow requires a credential to be used in a logical pattern. In other words, a card must be used at an out reader before it can be used at an in reader. Tailgating is a problem that is related to passback. It's also known as piggybacking. Once a door has been opened by a credential, more than one individual pass through the open doorway. Detectors can be set up using alarms that are based on sensors hung on the doorframe. And these are configured to compare movement of a single individual against the expected or normal movement. If an individual moves in an atypical direction or pattern, the alarm will sound. This issue can be addressed in a few techniques that I've detailed here. Hold open alarms monitor door contacts to check whether the door is closed or not. If the door contact doesn't close, then a door alarm can occur after a few seconds. This warns that multiple people are passing through a door that's been held open. As a warning, however, this type of alarming can be the biggest source of nuisance alarming, can be very irritating and ineffective after a certain amount of time. Turnstiles and revolving doors have moved from massive noisy devices to sleeker, architecturally styled access points. These devices can restrict entry to one person at a time. Obviously, they're not appropriate in every situation due to cost and space issues. A man trap is a device that's used a lot by law enforcement. It uses access control doors that are installed in a series. They're intended to close and lock in sequence, trapping a person between the doors. This is used most frequently in jails, prisons, or law enforcement buildings. It's highly controlled access for secure areas. Police use it as an inspection point for contraband. Man traps also function as airlocks for segregated clean room environments. A tailgating detection method could also use video analytics-equipped IP surveillance cameras. Video analytics use the digital video and complex algorithms to determine movement within the IP camera's field of view. And in a special use access control, elevators are not quite the same as man traps and don't directly apply to tailgating, but the elevator is a logical place to screen authorized access for highly secure floors. If you've got entire floors that are secure, providing access control at the elevator allows you to screen users from inside the elevator. Along the same lines, a sally port is typically used by law enforcement for entry into a secure area. The secured garage has a drive-through doorway, so vehicles can pull in up close to the entry door. And the sally port's designed so law enforcement agents can bring a prisoner directly to a secure entry to a holding facility. Prisoner can be unloaded from a police vehicle behind locked doors, preventing the possibility of escape during transfer into the building. Door propping is very common. Who hasn't propped a door open to prevent having to unlock it again? It's a classic convenience versus security problem. But an unlatched door could happen for other reasons. In case of the hardware malfunction, faulty door parts like worn hinges or latches or closers that don't retract fully can keep a door unlatched, and thereby your facility is less secure. Door propping is hard to combat. The simplest tactic is using signs and educating employees. Installation of hold open alarms and another common prevention technique it can be used. Installing and configuring alarm sensors can enable the system to sound an alarm when the doors don't shut within a specified range of time. Maintenance of faulty latches and door closers should be scheduled for regular maintenance to take care of equipment issues. All right, in our best practices section, in the spirit of good communication, departments should have a formal line of communication in regard to how they deal with their access control policies and procedures. Human resources comes into play here. They should keep an open line of communication with security, building management, and coworkers. When an employment status changes, human resources needs to inform the security of the change. If there's a termination, a relocation of an employee, promotion, for example, then security needs to know about it. Security needs to respond accordingly with access control changes. Network and email access should be shut off as well. In the spirit of good communication, security should report out to let HR and managers know if a configuration change occurs to credentials. And this helps to close the communication loop. Security or HR need to physically collect employee credentials when the employee is terminated or transferred out. The protocol needs to be determined in advance to determine who takes care of that responsibility. And this helps to mitigate the potential for misuse. A good practice is not wasting time in updating the cardholder database. Good record keeping and updates to the database will help prevent problems where there are discrepancies. This means cleaning up old entries, turning off unused credentials, reassigning old credentials to new users. If you let this task lapse, then cleaning up later can create preventable issues and workload problems. Addressing it quickly can relieve operational questions and prevent confusion down the road. Having an updated cardholder database allows for a more accurate operational response. If you have a lockdown situation, the UDER database has crucial information for management and emergency responders. Regular maintenance of your records might help also improve functionality of software and improve database performance. Some companies reuse credentials. They don't personalize those key cards as an ID badge. So just collecting the credential doesn't provide enough safety. You have to take the time to remove the credential from the database. This prevents theft and sloppy record keeping. A best practice for administrators is to pull a usage report regularly to see which cards are being used and which are not. This will help identify old credentials that should be deactivated. We promised a quick review for those who missed last month's webinar. In case you missed part one of this series, I have a link at the bottom of the page that directs you to the recording on the Lensec website webinar archive. The first part covers components and concepts of access control. So we'll quickly address several highlights from that webinar. Rules and standards for access control are taken more seriously by authorities because of a direct connection to the safety of the building occupants. Access control can more directly impact building occupants than surveillance video, for example. That's why we use building and fire codes as our primary resource when planning an access control project. The NFPA, or National Fire Protection Association, is a great resource for information on building codes. Most municipalities rely on codes from the NFPA, but make sure you check your code date. Sometimes the municipality is using an older code date. You want to make sure you're on the same page. Probably the most important code reference is NFPA 101. That's the Life Safety Code. This code covers building construction, protection, and occupancy ratings, covering issues of life safety. NFPA 72 is really a fire alarms code, but it affects access control due to integrations with life safety systems. Now, when in doubt, rules and regulations about those, you should make sure you contact the AHJ, also known as the authority having jurisdiction. That's typically the fire marshal or building inspector, depending on the agency. Our main goal here in referring to codes is to consider life safety. Our primary directive is life safety above all else. As a resource for you, I've also included a link at the bottom for the NFPA Codes and Standards site, and also the International Building Code, which is another potential code source. So, true or false? Let's get last poll launched. Most doors default to fail safe if you don't have a direction from or from the specifications or the authority having jurisdiction. So you have a 50-50 shot here. Give you a moment to get your vote in. All right. So 33% say true, 67% say false. The correct answer here is true. Most doors default to fail safe if you don't have direction from the specifications or AHJ. So let's take a look and hide that poll. All right, so we go over this extensively in our previous webinar. Failsafe and FailSecure are very important concepts for access control, and they're worth reviewing. Failsafe is when the electronic locking device is released and unlocked when power drops. FailSecure is when the electronic locking device is secured or locked when power drops. And you should find clear references for these cited in your specifications or your building codes. But when in doubt, most doors will default to FailSafe. It's important to know that FailSafe and FailSecure reference entry control only. It does not apply to egress or exit. Manual egress should be allowed at all times. If you don't plan manual egress, you could be trapping occupants in a building in the event of an emergency. So let's take a quick look at locks. Choosing locks will depend on the door type. Access control hardware usually involves door hardware such as electric strikes or mag locks. You want to make sure you assess which type you'll need for specific doors. It's not a one-size-fits-all scenario. Choosing the right lock can be complex, and you don't want to tackle this as an amateur. A cylindrical lock is usually used for interior or low security doors. A mortise lock is very durable and the most secure. It does require a precise cutout in the door, so you want to be careful about that. A surface lock mounting on the interior surface of the door, there's minimal prep and with exit devices on egress doors. Deadbolt locks are are used to enhance the security of existing locks, and your dead latch locks are typically a hybrid mortise of a deadbolt lock. The mag lock mounts to the surface of a door and frame, and it provides a strong magnetic bond holding the door secure. Mag locks are good fit for high traffic exterior openings, and they can have a bond rating up to 2,700 pounds. By design, mag locks require electricity to operate, and they're fail-safe by default. A mag lock should never be installed with a battery backup. When power drops, the lock must release and allow for the building, allow people to exit the building. An electric door strike is more common, a door component that receives an electrical impulse to engage or disengage the device. The door latch or lock remains engaged, and the strike activates what's called a keeper to allow or deny entry and exit. An integrated lock set is a hardware assembly containing all the components required to be fully functional, a self-contained device used for securing a door. Exit devices should be a part of your access control design plan. They're required in public buildings and classified as commercial or industrial. A PIR RTE device uses passive infrared motion sensors that can release the door automatically as a person approaches. A push button RTE is a simple device that releases the door when it's manually pressed. A crash bar placed on a door will release the lock automatically when the crash bar is pushed. And it's probably the most common exit device, the crash bar is. So credentials come in a few different form factors. You probably know a lot of them: badge cards, clamshells, which is a thicker type of badge, and a key fob. You have to remember that there are a couple of different types here. You have what's called prox cards and I-class cards. Make sure you know which type you need. The biggest difference between the two will be a frequency type. A common authorization interface is a card reader. The card reader is an authorization interface that picks up the credential data and passes it to the door controller. It needs to match credential frequency and the protocol for the door controller. We cover that in a great deal in last month's webinar, so you can take a look back and see that. The door controller may be hiding in the wall or ceiling crawl space. Some door controllers are IP-based and connected to a PoE switch, and some are hardwired with an access control bundled cable. Door controllers process the info from the credential, and then they hand off the data to the access control server. The controller will also hold on to recent credential information in its memory in case communication with the server is disrupted. In these circumstances, the controller can actually authorize entry until server connection is restored. So we previously talked about different types of authorization interface. We'll cover a few more of those in a moment. Let's quickly review authorization factors. Using more than one authorization factor is called multi-factor credentials. They build on top of one another for added layers of security. The authorization factor groups include something you have. This is a credential or permission given to a user to keep with them for access, such as a badge, token, or key fob. And something you know is typically a code or a password kept private by the user, such as a PIN number. Something you are adds a biometric feature or a physical characteristic that's unique to the user and uses a fingerprint or a palm print, something physically the user has. Someone trusted verifies you. This is an employee or human who positively identifies or vouches for the user, such as an employee or receptionist that grants access based on familiarity. And these multi-factor credentials can be used in combination with one another. You can have one or two or three or four in very secure situations. See our security guard there is using 3 different items in that situation to verify that employee that's coming through. All right, so back to authorization interfaces. A card reader or a keypad is commonly used. When a keypad is used in combination with a card reader, For a two-factor authorization, your security becomes enhanced. If you use one or the other independently of the other item, then it becomes a less secure situation. Biometrics provides a newer technology and a different type of authorization interface. Biometrics use access control that can't be transferred using security devices like fingerprint readers, iris scanners, palm print readers, and more. There's a few types of eye scanner on the market. The retinal scan maps the capillary pattern of the retina. This is a thin nerve on the back of the eye. An iris scanner is also an eye scanner, but it focuses on the colored portion of the eye. Both offer high accuracy, though the eye scanner is probably more commonly used. Fingerprints are unique to every person. A fingerprint scanner is the most affordable and convenient method of verifying a person's identity. The user places a thumb or pointer finger on the scanner while the scan reads the print, and then it's compared to a database to validate the user. Now here's some new information that we didn't discuss last time when we were discussing biometrics. One problem that may not seem obvious is stolen fingerprints. There's even an instance of perpetrators using fake fingers to fool print readers. IPVM, a security industry resource, reports that people casting replicas of fingertips, they'll use a gummy bear candy transfer or super glue to capture a latent print. Reports of some suspects even using cadaver fingers have been reported. So here's how we get around that. We overcome the attempt to beat the system using a liveness detection solution. Many newer fingerprint readers are including validity scans to ensure the fingerprint is alive and authentic. The technology being included can use a couple of different methods. Tissue reflection is a common method for multispectral imaging. It uses IR light to examine the reflective contrast of a finger's skin. Heartbeat detection is a strong method that uses optical sampling rates to detect swelling in capillaries coursing with blood. And then dermal electric resistance reads a small but consistent electrical resistance in healthy human skin. This method it checks for a live body, but it's not reliable in wet or cold environments due to a change in the density of skin and blood in the tissue. So it really only needs to be used in indoor environments that are climate controlled. Unnatural analysis is probably the weakest method. It relies on software alone to check and determine authenticity. It compares the print against typical characteristics of a known fake print. So if the quality of the print scan falls below a certain threshold, it's considered a fake and access is invalidated. As an additional bit of trivia, Apple Touch ID on the iPhone uses unnatural analysis in its fingerprint scan. So when considering future of access control technology, we have to take a look at near-field communication called NFC technology versus Bluetooth low energy or BLE technology. Companies are lining up on both sides of the fence, declaring their technology as the next big thing. The concept in this tech involves using mobile phones to replace today's proximity cards to access facilities. Here's a little more info on the difference in the technologies. NFC is derived from RFID technology. The difference here is that NFC chips can be changed and updated over and over again. That means NFC can behave like a digital wallet 1 minute and then used as a door access credential the next. A cumbersome problem is that an application needs to be started on the phone in order to make the NFC chip work. The alternative is BLE, which is a classic offshoot of Bluetooth. The biggest difference is it has a narrower range and lower bandwidth than classic Bluetooth. For a quick breakdown, taking a look at strengths and weaknesses, this chart shows us both are easy and secure. BLE wins the range contest, cost is better, and then NFC wins the power battle. All right, that brings us up to a point where we can take a look at questions and answers. See if we have any here. Let's see. What is ingress and egress? This is a topic I covered last month. Ingress is traffic that is flowing into the building. It's a common place to put an authorization point at building entrances. Egress is traffic that's flowing out of the building. Sometimes in a higher security setting, authorization might be logged at the egress point of the building as well. You might have a card reader on both sides of the door. So ingress is going in, egress is going out. Okay, let's see what else we have here. When you're evaluating a request for proposal to decide if you should pursue an access control project, are there certain things to keep in mind? Where should I begin? That could be a whole webinar in and of itself. RFPs, or requests for proposals, are notoriously vague and usually don't give you all the answers to your questions. That's where the building code and conversations with the AHJ come in. You may not do that research until after you win a project. A typical RFP usually does a great job of lining out a contractual language from the agency or owner's point of view, but a contractor typically has to make a lot of educated guesses when they're preparing a project for bid in terms of determining a realistic scope for the project. Covering your bases, you want to make sure you cover your bases and ask a lot of questions. If you have a chance to go on a site visit, go. It's well worth your time to walk the installation site, get a picture in your mind about the entire scope of work, and take actual pictures of various different areas so your technicians can see what's going on there, and determine how that affects your part of the project. Go and actually see the door openings. If it isn't a new construction, you might have that opportunity. A picture is literally worth 1,000 words in this situation. The contracting agency or owner will hold you to the contract in spite of lack of details in the RFP. So you, as the contractor, want to assume that you have your bases covered if you choose to enter into a contract with the owner. Okay, here's a good one. There are a lot of things to consider when planning access control projects. How do you make sure your bases are covered? I recommend being very thorough, and you may not want to tackle an installation on your own as an amateur. You want to make sure that you have the right team put in place, and that may require an outside vendor or contractor to assist. There are just some things that require skill to accomplish. For example, if you've never cut into a door before, to install a mortise strike, you might consider whether you would want to buy a replacement door or just hire the right guy with the right certification to do the job the first time. If you do plan to do many of those, then you might want to get trained and certified as an installer. There are several places that you can receive certification. Some are general certificates, such as those presented by security industry associations. Manufacturers will also provide training as well, including details about their product. I recommend doing a lot of research on your own. Tackling a large scope project will require some forethought and planning to make sure that your bases are covered. By the way, we are covering a webinar coming up next month called Planning for Your Security Technology Upgrade. So you want to make sure that you take a look at that. We'll go over a lot of these items in that webinar next month. Okay, let's see. What is the difference between an access control panel and an IP-based or server-based access control system? Well, we didn't get at that too much in our presentation due to a lack of time, because we just don't have time to address everything that's needed here. Sometimes access control training can take days to complete. Some access control systems have no server. The system controllers or panels contain the hardware for administering the system. Under these circumstances, you basically have a server that's built into the panel, and no external server is needed. You'll find this is more common in a small or a highly dispersed access control system. An example of this is Access Entry Manager. It's available for access security systems. This solution is not full-featured. It's not an enterprise-level system. It's only designed to control up to 66 doors, and it might miss out on several nice-to-have features. What about fire doors? Why are they fail secure? Well, it's critical for fire doors to stay closed during a fire, and there's a very good reason for that. A fire door provides a structural barrier to prevent a fire from spreading throughout a building. It's also a life safety issue. While it may not make sense to lock a door during a fire, keep in mind that these are doors that are not designated as emergency exits. Emergency exits must allow egress at all times. A fire door keeps the fire contained in specific areas and keeps it from jumping over to other parts of the building. When we're saying fail secure, that means the door locks when power fails, and careful planning is required around fire doors. If you have more questions about Failsafe or FailSecure, take a look at part 1. I've heard of a delayed egress door. What is that? Well, a delayed egress door, also can be referred to as a nanny door. It's a system that rarely locks the inhabitants in. They're used sometimes in nursing facilities or psychiatric wards in hospitals. These doors are subject to a special authority, and they're going to be governed by code. The code will cover specifics like how long the delay period can be before the door releases. 15 to 30 seconds is common, and they can even sound an alarm before opening to notify employees of what's going on. So let's see, any other questions here? No other questions, so we'll wrap up a few minutes early here. Don't forget, we'd like to have attendees complete a quick survey at the end of the webinar. Once you complete the webinar, you should get a survey to fill out. On that, you can request a completion certificate for the webinar if you'd like. We'll email out those after the webinar is done, and we'll also send answers to questions that came in today. This webinar recording will be posted on our video archive on the Lensec website in a few days. You'll find it at www.lensec.com, along with previously recorded webinars covering a variety of topics related to physical security. My name is Keith Harris with Lensec. If you have additional questions, feel free to contact me directly. That wraps up our webinar. Thanks everyone for attending today. We'll see you again next month with another installment of our Step Into Security webinar series. In July, we'll be talking about planning for your security technology upgrades. Please register for that. We have details available on our website, and we'd invite you to join us and share that information out with your friends. Thanks for making time for us today. We appreciate it.